Hey, welcome to The Explainer. Today, we're going to be unlocking one of the most famous, and maybe one of the most feared, equations in all of mathematics. You've definitely seen this one before, but I'm willing to bet you've never seen it quite like this.
Yep, there it is, the quadratic formula. For so many of us, this was just something you had to memorize for a test, right? A mysterious string of letters and symbols that somehow, magically, gave you the right answer. But where does it actually come from? Today, we're not just going to use it, we're going to build it from the ground up so we can really understand it.
So while we all just call it the quadratic formula, it actually has a proper name, the Sridharacharya Sutra. That's right, it was developed way back in the 9th century by a brilliant Indian mathematician named Sridharacharya. He created this super elegant tool to solve equations with a squared variable, a problem that came up all the time back then and still does today. Okay, so to understand the solution, we've got to start with the problem itself. Our whole journey begins with the standard form that every single quadratic equation takes. This right here is our foundation. Ax squared plus bx plus c equals 0. Now, a, b, and c are just placeholders for numbers, but there's one really crucial rule. A can't be 0. And that makes sense, right? If a were 0, that x squared term would just disappear, and, well, it wouldn't be a quadratic equation anymore. Our mission, should we choose to accept it, is to find the value of x that makes this whole thing true. All right, now for the really fun part. We're going to take that standard equation and we're going to morph it one logical step at a time until it actually becomes the formula we all know. Think of it like we're solving a puzzle, and these are the first few moves we need to make. First up, we divide everything by a. Why? Honestly, it just makes our lives easier by making that first term a simple one. Then we take that constant, the c over a part, and we just nudge it over to the right side of the equation. See the goal here? We're trying to get all the x stuff on one side and all the plain numbers on the other. And here's where we hit our first major challenge. That expression on the left, x squared plus b over ax, it's kind of awkward. We can't just take the square root of it and call it a day. So how in the world do we turn this into something we can solve? Well, the answer is this incredibly clever algebraic technique, and it's called completing the square. This is our master key. The whole idea is to add one very specific, almost magical value that will transform our messy little expression into a perfect, tidy square. It's awesome. Okay, here's the big move. We're going to add the square of half of that x coefficient. So that's b over 2a squared, and we're going to add it to both sides of the equation, to keep everything fair and balanced. And boom! Just like that, the left side magically factors into the perfect score you see right there. This one step is what makes the whole thing work. It's brilliant. From here, we're on the home stretch. The puzzle is basically solved. We can now take the square root of both sides. Just remember, when you do that, you have to add that little plus or minus symbol on the right, because a positive or a negative number could have given us that square. Then the very last step is easy. Just subtract b by 2a from both sides, and x is finally all by itself. And after all those logical moves, after all that rearranging and completing the square, we've arrived. We made it to our destination. We haven't just memorized a formula. We actually derived it ourselves. Hey, look familiar? It's the same formula we saw at the start, but now it's not so intimidating, is it? It's the result we earned from our step-by-step journey. Every single piece of it, the negative b, the plus or minus, that 2a on the bottom, it all has a reason for being exactly where it is. But the story doesn't quite end there. The formula's true power isn't just in finding x. It can actually tell us a story about the equation itself, just by looking at one tiny little piece of it. Let's zoom in on that part right underneath the square root sign, b squared minus 4ac. This little expression is like the heart of the formula. It's the engine that holds a special kind of predictive power. And yeah, it's so important, it even has its own name. This is called the discriminant, and you'll often see it written as just a capital D. Its job is to discriminate, or in other words, to figure out the nature of the answers, or roots, of our equation. By just calculating this one value,
we can know ahead of time what kind of answers we should expect to get.
And here's what it tells us. It's super straightforward. If the discriminant turns out to be a positive number, we know for a fact we're going to get two different real solutions. If it's exactly 0, we'll get just one real solution. And if it's negative, well, you can't take the square root of a negative number in the real world, so our answers will be imaginary or complex. How cool is that? We get this incredible foresight just from that one little calculation. So in the end, the quadratic formula isn't just some rule you have to memorize. It's the final sentence in a long, logical story. And it proves that even the most intimidating-looking math is usually just built from a series of simple, understandable steps. Which kind of leaves us with one last thought, right? What other formulas that we just take for granted are out there just waiting to tell us their story?